So after your quiz, you should be taking these notes on your own, and then there's going to be a big ideas math homework that goes along with it. Okay, so we're actually jumping to section 10.4. Okay, we're not going to do all the sections in chapter 10. We're only going to do a couple, 2 or 3, and then we're going to do the first few in chapter 11, put those together. Okay, now some vocabulary. You should know all of these words, okay, because they were all on your quiz. Okay, they were on that vocab thing that we did, and they were all on your quiz. So a chord, as a reminder, is a segment in which both endpoints lie on the circle. Okay, so if I want to draw this on this circle here, okay, this, we're pretending that's a straight line, would be a chord. Okay, now an inscribed angle, okay, and it is an angle in which the vertex is on the circle and the sides are chords of the circle. Okay, so let's look at what that looks like. Okay, so the vertex is on the circle. So let's say the vertex is here, and then each side is a chord. So we have one chord here, another chord here. Okay, this here would be an inscribed angle. Now, an intercepted arc, okay, is going to be this arc that's like trapped between this angle. Okay, think of it as like the two chords kind of stranded and isolated. Okay, so an intercepted arc is an arc that lies between two lines, rays, or segments. Okay, an inscribed quadrilateral, guys, we should know a quadrilateral has 4 sides. Okay, it's a quadrilateral in which all 4 vertices lie on the circle. Okay, so if I have a circle here, we'll pretend this is a perfect circle. Okay, if I just draw any 4 points on the circle, okay, and then I connect them to make a quadrilateral, okay, this would be an inscribed quadrilateral. Okay. Now, an inscribed triangle, it's the same thing. All 3 vertices lie on the circle. So if I say this vertex, this vertex, if I connect them all, okay, there's my inscribed. Okay, now a circumscribed circle, okay, you can't have a circumscribed circle without an inscribed polygon. Okay, so the circumscribed circle is the circle itself that just contains the inscribed polygon. Okay, so a circle that contains all the vertices of an inscribed polygon. Okay, something you need to note that you're going to see, okay, is that circles are named according to their center. Okay, so if this is the center of the circle, and let's say this is point P, okay, we would name this as circle. That's the, I guess, symbol for circle. We would name it circle P because P is the center. All right, so the first theorem we're going to cover today is the measure of an inscribed angle theorem. Okay, now, if you don't know what an inscribed angle is, you need to go back up to the top and look at a picture and understand what it is before you can understand this theorem. Okay, so the measure of an inscribed angle is going to be 1/2 the measure of its intercepted arc. Okay, so there's this 2-to-1 ratio. Okay, so for example, okay, if this intercepted arc, let's just, to make things easy, let's just say this is 100 degrees. So from here to here is 100 degrees. Okay, this angle is going to be half that, meaning that it is 50. Okay, you can think of it that way, or another way you can think of it that says the same thing is that the intercepted arc is twice or 2 times the measure of the inscribed angle. Okay, those 2 things are saying the exact same thing, just in a very different way. Okay, so let's look at example 1. Okay, if we know this is 50, okay, if I draw this angle here, this is an inscribed angle. Okay, the intercepted arc for this, so the arc trapped between those two sides, would be this. Okay, now according to this theorem up here, okay, I'd actually use this one here. The intercepted arc is twice the measure of this angle. Okay, well, if this is 50, this has to be 100 then. Okay, so arc QT, okay, so we would say QT with an arc mark over it. This is arc QT. Okay, this would be 100 degrees. Okay, now we want to find angle T. Well, notice angle T is right here. Angle T is an inscribed angle. Okay, now its intercepted arc is right here, and it's 48 degrees. Okay, so we're going to use this part of the theorem here that says the measure of an inscribed angle is 1/2 the measure of its intercepted arc. So the measure of angle T would be 1/2 of 48, which is just 24 degrees. Okay, so if you know the theorems, you should be able to apply them easily. Okay, now on this one here, okay, we know that the measure of ZYW, so this angle right here, right here is 80 degrees. Okay, and that means that this right here has to be double that, right? Because to draw this angle, be here and here, so that's its intercepted arc, so this has to be 160. Okay, we also know that angle XWY, so XWY, so this angle right here, okay, we know that's 35 degrees. And if that's 35, this has to be double that, so this has to be 70. Okay, now I want you to pause this and I want you to try to find these 4 items, okay? We've already done a lot of the work, but look and find some. We may have already found some, I don't know. Okay, now do take note that when we're talking about arc measures, okay, we go the shortest distance. So when we're talking about WZ, the shortest distance from WZ is from here to here. Okay, otherwise I'm going more than halfway around the circle. Okay, so this we actually already found is 160. Okay, if it wanted me to go the long way, it would give me another letter. So like WXZ, that would mean go the other way. Okay, so that should help you. So like on this one, there's 3 letters, go in the order of that. So like arc XWY would be arc X2W to Y, which is right here, which would be all the way around except this here. I just did another one for you. So that would just be 360 minus 70, which is 290. Okay, I found the 2 arcs. Okay, now pause it and find the 2 angles. Okay, so hopefully you paused it and found these 2. Okay, so the first one is find the measure of WXZ. So WXZ would be this angle right here. Okay, so if I draw this angle, WXZ, okay, here's my angle, and notice that it has the same intercepted arc right here as 160. Okay, so that means that the angle has to be half of 160, which is going to be 80 degrees. Okay, now let's look at our other angles. So our other angles, YZX, so YZX. So this right here is YZX, right here, this angle. Okay, and notice my intercepted arc is right here at 70. Okay, and according to this theorem, the angle is half the arc, so half of 70 is 35 degrees. Okay, we did all these just using this theorem here.